Am I not visible? Students, can you able to see me? Yes, right? Okay. I think the person who is sitting behind the ID Acer, we have to check your network connection because I am visible and audible to others. So please check it. All right. So very good evening to all of you. So let's go ahead with today's class. So we are discussing about aldehydes, ketones, and a carboxylic acid for the past 4 classes, right? We have successfully completed the aldehydes and ketones. I have completed, but I hope you also have completed the aldehydes and ketones. Now I am visible, my dear. Okay, that's good. Good. So I hope you guys also have started revising and completed the aldehydes and ketones part of this lesson thoroughly. Am I right? Did you guys do that? Okay. So if you have not started this lesson yet, please start at least today and go through the topics that we have covered so far. Okay. So now we are into the topic called preparation of carboxylic acid. We have completed the other two. So we have entered into the preparation of carboxylic acids. Okay. So there are 3 topics we have to discuss under this. One is preparation of carboxylic acid. The other one is physical properties. The third is chemical property. And the fourth one is uses. Okay. The very main topics are preparation, physical and chemical property. So as I have said that we have 5 preparations of carboxylic acid. And out of 5, we have already completed 2, right? So do you guys remember those 2 preparations of carboxylic acid? Yes. So the first preparation is from alcohol, from primary alcohol, right? So we have used oxidizing agents to prepare the carboxylic acid from primary alcohol. Then secondly, we have prepared from alkyl benzenes, right? Alkyl benzene. So we have took some alkyl benzene. For example, if I take methyl benzene and if I treat this with KMNO4, it is also called as oxidation only, KMNO4 in presence of OH minus. So this CH3 group will be converted to COOH group. It will be converted to COOH groups. So the alkyl benzenes are oxidized to give the corresponding aromatic carboxylic acids. Okay, so these are the 2 preparations which we have seen so far. Now, today we are entering into the third preparation, that is from nitriles and amides. So what are called as nitriles? RCN is called as nitrile. RCN is called as nitrile. So if you take this nitrile and if you hydrolyze with the water in presence of acidic medium or basic medium, it will produce amides. It will produce amides. RCONH2 is called as amide. Okay. If you still hydrolyze the amide in presence of heating, you will get the carboxylic acid. You will get the carboxylic acid. So what is happening here? The CN group is getting converted to CONH2. CONH2 is getting converted to COOH. So this is the conversion. So this is the conversion. Okay. JNV Anam students, are you trying to record the session? Are you trying to record this? You want the recorded session of this class? JNV Anam? If you want to see the recorded session, my dear, it is there in the YouTube. You can go there and see, okay? So I'm declining the request right now. Okay. So what I was saying, yeah. The nitrile is getting converted to CONH2 and that is getting converted to COH. You should learn the conversion factor. Okay, the conversion part is very important. Whatever might be the compound given to you, if you know the conversion on doing the reaction with the specific reagents, you can find out the correct answer. You can find out the correct answer, okay, without any hesitation. All right, shall I go for one example? Can you guys find out? Can you guys find out the answer? So I will give you nitrile. You try to find out the amide and carboxylic acid. Okay. So the nitrile is CH3CN. Since there are two carbons, it is a ethane nitrile. So if I put this ethane nitrile in water, what will happen? What I will get? What I will get? Or what is the formula of the compound? What is the formula of the amide? Yeah. CH3CONH2. Very good. Ethanamide. It is called as ethanamide. Then ethanamide on treatment with H plus and OH minus will give ethanoic acid. Ethanoic acid. Very good. Very good, Aishwarya. It is CH3COOH. You have added one H. It is by mistake only. No problem. I was just kidding. So ethane nitrile, CN is getting converted to CONH2 and CONH2 is getting converted to COOH. Okay, so this is the thing you have to keep in mind. This is the third method of preparation. Then the fourth method of preparation is from acyl halides, acid anhydrides and ester. So what is the formula for acyl halide and how can we prepare? Okay, so we can prepare using acidic hydrolysis. Acidic hydrolysis means using an acid in presence of water, we will do this reaction. Okay, acid means H plus, hydrolysis means water. Reaction of water with H plus into acyl halide. Acyl halide formula is COCl. RCOCl is acyl halide. RC double bond O Cl. Okay, if you treat this with water, the COCl part will be converted to COOH with the removal of HCl. Okay, and the second compound is acid anhydride. So this is the formula. R C double bond O C double bond O R. So RCO is repeated 2 times with 1 oxygen in between. Okay, so this is acid anhydride and it will also produce acid. Okay, carboxylic acid. And thirdly, ester. R C double bond O R dash. So here also the COOR is getting converted to COOH. Clear? So we are using acid and with water, the 3 compounds are getting converted to carboxylic acids. Clear? Clear for all of you? How anhydride will break? Okay, I will explain. I will explain the breakage of all the 3 compounds. Okay. So if ROCl is treated with water, this CCl bond, it will be broken down like this and we have to add OH and H like this. Water will get added to this and we get RCOOH and HCl. Okay. And here we have 2 CO bonds, right? In case of acid anhydride, we have 2 CO bonds, right? You have to break any one of the CO bond. Let me break this bond. So I will add H to one side and OH to another side. So I will get RCOOH and RCOOH. So there are 2 moles of RCOOH is formed like this. Is it clear? Is it clear? In case of ester also the same thing. You have to break the CO bond, add OH and H like this. So I will get a carboxylic acid as one of the component and R-OH will be the other component. Alcohol will be the second component. Okay. Great. Now let's go for some examples. Let me take an example of an ester. So I have taken an ester. So C6H5 is R, COO, R dash. This is an ester. So what is forming here? You see the CO bond, this CO, C6H5, C double bond O, OC2H5, right? So break the bond, add OH and H like this. Okay, you will get benzoic acid as one of the product and ethanol as the other product. Okay, so benzoic acid and ethanol is forming here. Basic hydrolysis will also give alcohol, but not carboxylic acid. Instead of carboxylic acid, it will produce carboxylate ion. So from acidic hydrolysis, we are getting the acids, right? From acidic hydrolysis, we are getting the carboxylic acid, COOH component we are getting. But if you are using a base, instead of H plus, if you use OH minus, then in that case, you will get RCOO minus. Okay, RCOO minus. So this is called as carboxylate ion. So carboxylate ions are produced from basic hydrolysis. Okay. The remaining things are same only. This is all about the fourth preparation. Then coming to the fifth preparation. Fifth preparation is from Grignard reagent. RMgX is called as Grignard reagent. So I am going to take that compound and treat it with CO2. What is CO2? Carbon dioxide or dry ice. CO2 is also called dry ice. And if you treat it with H plus and H2, you will get carboxylic acid. So how does it form? Let me show you the mechanism. It is very easy. So take RMgX and treat it with CO2. Okay. So the R group will go to carbon and the remaining will go to oxygen. So what I'm doing is I'm having C double bond O, right? So break one of the C double bond O, add the negative part to carbon and the positive part to oxygen, so that we will get a compound like this. Okay. R group has been added to carbon and the MgX has been added to oxygen. Then I have to do this hydrolysis, right? And I have to do. So here, if you do this hydrolysis, you have to break this OMG bond. Add H and OH like this. So you will get RCOH and MgOHX. MgOHX. Okay. So initially I have only one carbon. But in the product side, you see, I have more than one carbon. If R group is CH3, then I will have CH3COOH, right? So initially in the carbonyl part, I have only one carbon, but in the product, I am getting more than one carbon. So this reaction is called as step-up reaction. Why it is called as step-up? Because the number of carbon atom increases in the product. Okay, it increases in the product. So that's why it is called as step-up reaction. Clear to all of you? So shall we go for one example? The example, I have taken ethyl group as an example. Okay, CH3, CH2. So I am getting CH3, CH2, COOH. Ethyl magnesium chloride is getting converted to propanoic acid. Okay, propanoic acid. 3 carbon containing acid is called as propanoic acid. Do you have any doubt from the preparations? Do you have any doubt from the preparation part of this? Do you have any doubt from the preparation part of this? No doubt? Okay. So let me summarize the preparation that we have studied. So the very first is from alcohol. Second is from aldehyde. Aldehyde also can be converted to acid by usage of the oxidizing agent. Then second is from alkyl benzene. Then we have discussed from acyl chloride, acid anhydride and ester. And also we have discussed the preparation from nitrile. And that last we have discussed from Grignard reagent. So these are the 5 preparation. 1, 2, 3, 4 and 5. So these are the 5 preparations of carboxylic acid from the compounds. Okay. So now let us go for the second topic, physical properties. So what are the physical properties of carboxylic acid? So first let me talk about the physical state of the carboxylic acid. Okay. Lower fatty acids up to carbon number 10 are colorless. First is about the color. Okay, first is about the color. Carbon number 10. Till carbon number 10, all the carboxylic acids are colorless liquids, but the higher ones are colorless waxy solids. So if the carbon number increases, the physical state is changing from liquid to solid. Physical state is changing from liquid to solid. Okay. And coming to the next point. Next is about the smell. First 3 members have a sharp, pungent odor. Pungent means bad smell. Okay. And carbon number 4 till carbon number 9 have an odor of rancid butter. Rancid butter means rotten fish, rotten egg kind of smell. Okay. So it will not be good. Whereas higher members do not possess any smell. If you have more than 10 carbon or more than 9 carbon, if you go, they won't have any smell. Okay, this is about the odorless. Then the third point is about the solubility. Lower members are soluble in water, but the solubility decreases with rise of the molecular mass. So solubility decreases with increase in the molecular mass. So they are inversely proportional. They are inversely proportional. The first point is about the physical state. The second is about the smell, odor. The third is about the solubility. Fourth physical property is about boiling point. Boiling point of carboxylic acids are higher than those of alcohols. So far, alcohols had the highest boiling point compared to other compounds, right? If I compare alcohol with aldehyde, if I compare alcohol with ketone, if I compare alcohol with hydrocarbon, with the ether, with all other compounds, if you compare the alcohol, alcohol had the highest boiling point value. But now, carboxylic acid is beating the alcohol, right? Carboxylic acid is having the highest value compared to alcohol. The very important reason is due to intermolecular hydrogen bonding. What is meant by intermolecular? Between 2 molecules. If the hydrogen bonding is existing between 2 molecules, it is called as intermolecular hydrogen bonding. So let me take 2 carboxylic acid for you. Okay, 2 carboxylic acid, 2 ethanoic acid, CH3COOH, CH3COOH. So the oxygen of one molecule is able to form the hydrogen bond with the hydrogen of another molecule in the same way. Oxygen of the second molecule is forming the bond with hydrogen of the other molecule. So 2 hydrogen bondings are formed for one molecule. Okay, one CH3COOH is able to form 2 hydrogen bond. Okay, so hydrogen bond is formed between 2 molecules and one compound is able to form 2 bonds. So both are very strong. So it cannot be easily be broken. That's why the compound will take high temperature to get boiled. Okay, so that's why the boiling point increases for carboxylic acids. Clear? So these are the important physical property you should know about this carboxylic acid. Any doubt here? Shall we go for the chemical properties? Shall we go ahead with the chemical properties? No doubts, students? Shall I go into the chemical property? Give me your answer fast. We are having only very less amount of time, no? Say yes or no. Okay. Okay, good. So the next is chemical properties of carboxylic acid. You understand, Aishwarya? That's very good. Good. So try to interact. Don't get scared. Try to interact. You don't have to get scared. Okay. So there is an issue with my PowerPoint, I think. It is not working. Can you all able to see the screen? Is it visible? Okay, fine. Okay, fine. Now it is all right. So under the chemical property, we are going to learn some reactions. All the reactions are very important and easy. All the reactions are very important and easy. So for your convenience, you see, I have divided the reactions of carboxylic acid into 4 categories like this. Okay. So into 4 categories so that it will be easy for you to understand. First is the reaction involving the breakage of OH bond. Okay, breakage of OH bond in carboxylic acid, this bond. The reactions which are falling under that category, under the breakage of this OH bond will fall here. Then breaking of CO bond. Then the reactions involving the breaking of CO bond. CO bond means this bond. Okay, this one. Carbon, oxygen, single bond, not double bond. Then third is the reactions involving COH group as a whole. So here in the third category, the whole group COH will be converted to some other group. Okay, so those will fall under third category. And fourth is the substitution reaction. You all know what is substitution, right? So one element will come and substitute the hydrogen present in the compound. Okay, so those type of reactions will come under the fourth category. And finally, we will discuss about the uses and we will wind up the lesson. All right. So let me go for the first category. Reactions involving the breaking of OH bond in RCOOH. Okay. So under this category, there are 3 reactions. Under this category, there are 3 reactions. The first is the reaction with sodium. And the second is reaction with sodium hydroxide. Third is reaction with sodium bicarbonate. So that I will show you in the next slide. The reaction with Na is the first reaction. Sodium is a metal. Sodium is a metal. So let us study the reaction of carboxylic acid with the metal. So see here, we have a carboxylic acid and it is treated with a metal. So the OH bond is getting cleaved and sodium is taking the place of hydrogen. So we are getting sodium salt of carboxylic acid. Okay, so let me take an example. Acetic acid is taken as an example. So what I'm getting here, sodium ethanoate. This is called as sodium ethanoate is formed. And coming to the reaction sodium hydroxide with NaOH. With NaOH also, the OH bond will get cleaved, but hydrogen will come out with OH as water. Product remains same. RCONA is a product. Byproduct only differs. So here I am getting H2 with the sodium metal and here I am getting H2O, water with sodium hydroxide. You see in the example, we are getting water as a byproduct. The only difference is the byproduct. Main product is same only. All right. The third reaction is reaction with sodium bicarbonate, NaHCO3. NaHCO3. So here if I treat this carboxylic acid with NaHCO3, again the main product will be same. The byproducts are different. 2 byproducts, carbon dioxide and water are coming out as a byproduct. Carbon dioxide is a gas, right? It will evolve. If this is the reaction mixture, carbon dioxide will come out. You can able to see the brisk effervescence, right? Brisk effervescence means the bubble kind of thing. So that is a carbon dioxide gas which is coming out from the container. Okay. So in all the three reactions, the byproduct is changing, the main product remains same. Very easy. So do you have any doubts from these three reactions, which involves the breaking of OH bond? Is it clear? Can you all able to understand? Okay. What about others? What about others? Shaheen, Suraj, Priya, Parveen, JNV Kukreja student, Deva, Christina Priyadarshini, Bhagat. All of you are here only, no? Okay, understood. Good. So let me go for the second type. Reactions involving the breaking of COH bond in RCOH. Involving breaking of CO bond. So here, under this topic, the first reaction is formation of anhydride. Formation of anhydride. So just before few minutes, we have discussed about one anhydride, right? I also told no RCO O COR. So this is the general formula for anhydride. So let us form this compound from carboxylic acid. So to form this compound, I have to take two molecules of carboxylic acid, RCOOH plus RCOOH. Now you treat this carboxylic acid with H plus or P2O5. Okay, H plus on heating or P2O5. Either you have to do this or you can treat the compound with P2O5. Okay. P2O5 is the dehydrating agent. P2O5 is a dehydrating agent. Okay, what is meant by dehydrating agent? The one which is used to remove the water. Okay, H2O is removed. H2O is removed and this oxygen is getting connected to the carbon. You have to connect this oxygen with the carbon. So what will you get? RCOO, CO, R plus H2. So this is acid anhydride. So this is acid anhydride. Got it? Is it clear? So if you are finding any carboxylic acid with P2O5 or H plus in presence of heating, then straight away you remove the water and write the compound. All right. So let me go for the second reaction. Second is esterification. And one more thing I want to say. All of you can able to see how the CO bond is getting broken down, no? Here. Rohit, concentrated H2SO4 is also a reducing agent, dehydrating agent. But that will remove the water mainly from alkenes. Okay. So if you want to remove the water molecule from carboxylic acid, okay, which is a very strong agent, you need the dehydrating agents like P2O5 only. Okay. H2SO4 can also be used, but P2O5 is more appropriate. Clear? So in one of the molecule, the CO bond is getting broken. Then here in the esterification, you see. What is meant by esterification? Carboxylic acid reacts with alcohol to form ester and water. Yes or no? Carboxylic acid plus alcohol will form in presence of acid. In presence of acid, it will form ester and water. So the ester formation reaction is called as esterification. So here what we are doing, we are removing the water. And in the carboxylic acid, the CO bond is getting cleaved. Okay, so that's why esterification is coming under this category. Okay, we have studied, we have come across this esterification reaction in many organic chemistry lessons so far, right? The same reaction it is, but there is a cleavage of CO bond here. So that's why they have kept this reaction again in this part also. Okay. Shall I go for the third reaction? Any doubt so far? Okay. Third is the reaction with phosphorus chloride and thionyl chloride. So what is meant by phosphorus chloride? PCl3, PCl5. Thionyl chloride means SOCl2. Okay. So you can take any one of these reagents. I have three reagents. PCl3 or PCl5 or SOCl2. Okay. So you can use any one of these reagents. The CO bond will get cleaved and the OH will be converted to Cl. OH will be converted to Cl. Okay. So acid chloride is formed as a product. Among these three reagents, PCl3, PCl5 and SOCl2, SOCl2 is a preferable reagent because the byproducts which are formed by the reaction with SOCl2 are SO2 and HCl. Both of them are gases and they can come out of the container very easily. They escape out easily and we are left with only the acid chloride in the container. Okay. But if you go for PCl3 or PCl5, you have to use some separation techniques to separate the byproduct from the main product. Okay, because the byproducts are also a liquid. Okay, byproducts will also be a liquid. So the main product is RCOCl. Some other byproducts will be formed. If you treat the acid, carboxylic acid with PCl5, you will get POCl3, HCl as the byproduct. So what you have to do? You have to separate this POCl3, HCl and RCOCl. It takes some time. If you want to get the acid chloride immediately, then use SOCl2. Clear? We have already studied about this concept in haloalkenes lesson. If you have remember, I have taught this in the preparation of haloalkenes. That SOCl2 reaction is more preferable because of the same reason. Okay. So this is the third reaction. Fourth reaction is reaction with ammonia. Fourth reaction is reaction with ammonia. So here take carboxylic acid and treat it with ammonia, NH3. So they will produce a salt. RCOONH4+. This NH3 will go and get coordinated with this. So we'll get an ammonium salt. Then if you heat this, H2O will come out and we are left with RCONH2. Amide is formed with the removal of water. Okay. So example, C6H5COOH on reaction with NH3. First, they will produce C6H5COO minus NH4+. Then upon heating, H2O will come out and the remaining C6H5CONH2 is the amide, benzamide formed from this reaction. Okay. You can further heat this amide. You can further heat this amide with P2O5 and they will produce nitrite. So take the amide, RCONH2 is amide, right? So take the amide and heat it with P2O5 and heat it. So P2O5 is a dehydrating agent, I have told you. So water will be eliminated. H2O will be eliminated again. So one more mole of H2O will come out. The remaining RCN will be formed, which is a nitrate. Okay. Clear? Any doubt? Any doubt from this? So in the second category, I have discussed 4 reactions. In the first category, I have discussed 3 reactions. So now let us go for the third category, which is reactions involving COOH group as a whole. So here under this, the first reaction is reduction of COOH group. For the reduction, we need to use reducing agents. Lithium aluminum hydride, hydrogen in presence of platinum or nickel, and B2H6 in presence of H3O. All these are the reducing agents. So you can use any one of these. If I use lithium aluminum hydride, I will get a primary alcohol. If I use this, I will get a primary alcohol. You see the example? The 3 carbon containing carboxylic acid on reducing agent will give 3 carbon containing alcohol. Propanol is formed. Okay. Sodium borohydride does not reduce carboxylic acid. So you cannot use NaBH4. Okay. It does not reduce carboxylic acids, esters, epoxides, nitro compounds, and nitriles. But it reduces carbonyl compound and acyl chloride. Carbonyl compounds means aldehyde, ketone, and acyl chloride means it is RCOCl. So it can reduce these people and but it cannot reduce the carboxylic acid, ester, and other things. Got it? So the first reaction under third category is reduction. The second is decarboxylation. So what is meant by decarboxylation? A reaction with NaOH and CaO. Already we have discussed this also. Reaction with NaOH and CaO. So this is called as soda lime. This mixture is called as soda lime. And here the removal of Na2CO3 takes place with the formation of alkane. Okay. So it is called as soda lime process. It is called as soda lime process. So if you ask me an example for this, I can give you the ethanoic acid as an example. So what will be formed? RH will be formed. So CH3 is the R group. So CH3H will be formed with the removal of Na2CO3 and H2O. CH3 is actually, CH4 is actually methane. Okay. So what will be the product if I use benzoic acid as a reactant? Can you guess? Can you guess the name of the product that we get from this reaction? R group is C6H5. Yeah, very good, very good. The product is benzene. Very good, Aishwarya. Very good. Rohit, Deva, Parveen. All of your answers are correct. So we get benzene. Just learn the mechanism. RH is produced from the soda lime process. Okay, which is decarboxylation. Then the third is Kolb's electrolysis. You all know what is electrolysis. We have a beaker and we have anode and cathode dipped inside the beaker. And there will be one salt solution. And all these things are connected to a setup, electric circuit setup. And if we switch on, the reaction will happen. Anions will move towards anode, cations will move towards cathode, and this process is called as electrolysis. Okay. Now here, the acidic salt solution is the carboxylic acid salt solution. RCOO minus Na plus. This is the acid. So when it is put inside the water, it undergoes electrolysis and it will produce RR, which is an alkane. Again, it is an alkane. So initially I have only one R group. But in the final product, I have two R group. So alkane has twice the number of carbon atoms present in the alkyl group of the acid. Suppose if I have two molecules of CH3, COO minus, Na plus, with an electrolysis, it will produce, this is R group, right? So it will produce CH3, CH3 plus 2 CO2. Okay. So I have two carbon, which is an ethane. So in the reactant, I have only one carbon, but in the product, I have two carbon. Okay. Clear? So alkane has twice the number of carbon atoms present in the alkyl group of the acid. So if I am taking two carbon containing acid, I will end up with 4 carbon containing alkane. If I take 3 carbon containing acid, I will get 6 carbon containing alkane. Okay, so it will be the twice the number of carbon atom. Clear? So these are the 3 reactions under the third category. Now let me enter into the fourth category. Substitution reactions. So the very first substitution reaction is called as alpha halogenation. Okay. So let me take a carboxylic acid. And with the X2, X2 means halogen. In presence of red phosphorus and H3O plus, I will get a compound like this. This C double bond O is called as carbonyl carbon. And the carbon which is attached to it is called as alpha carbon. And this alpha carbon has 2 alpha hydrogens. Okay. One of the hydrogen is getting replaced by the halogen which we are taking here. So that's why it is called as alpha halogenation. Alpha halogenation. The name of the product is alpha halo carboxylic acid. Okay. So we have 4 halogens, right? Fluorine, chlorine, bromine, and iodine. But the halogen that you have to use here is chlorine and bromine, not fluorine and iodine. Fluorine is highly exothermic and iodine will undergo very slow reaction. So we don't use those two. So instead of those two, we'll go for chlorine and bromine. Okay. So this is a very important reaction, I can say, because it is a named reaction. Name of the reaction is Hell-Wollard-Zelensky reaction. Hell-Wollard-Zelensky reaction, which is also called as HPZ reaction. Which is also called as HPZ reaction. So if I'm having a compound of formula CH3, CH2, COOH like this, with chlorine and in presence of red phosphorus with H3O plus, what I will get? I have to look for the alpha hydrogen and replace that hydrogen by the halogen, chlorine and COH. That's all. This is the product. Very easy. So just memorize this reagent alone. Halogen with red phosphorus and H3O plus is the reagent for Hell-Wollard-Zelensky reaction. All right. This is the first reaction. Do you have any doubt in this reaction? This is important. Shall I go for the next reaction? Students say yes or no. Shall we go for the next? Yes. Okay. Okay. So the next is electrophilic aromatic substitution reaction. Again, this reaction follows in all the topics we are learning, right? So here, since we are talking about carboxylic acid, you can take benzoic acid as your reactant and do the nitration. We have 5 types. Do the nitration. Nitration means with HNO3 and H2SO4. So we will end up. So if these reagents react with each other, they will give the electrophile with the formula NO2+. And this NO2 plus will go to the meta position. Why it is going to the meta position? Can anyone tell me the reason? When I am talking about the aldehyde, benzaldehyde, I told you, right? So why NO2 is going to the meta position? Do you guys remember the reason that I gave you? Electronegative group, okay. Delocalization of electron. What is meant by delocalization? Delocalization electron. Yeah, delocalization of electron, and because of that, what is happening? The exact answer you guys are not giving. Resonance, no. Listen, COOH group is an electron withdrawing group. COOH is an electron withdrawing. So the incoming electrophile is going to the meta position. I told you, right? Very good. Very good, JNV Kokrajar. It is, what is your name? I forgot. Bishan, right? The one who is watching from JNV Kokrajar is Bishan, no? Yeah, good. Bishan answer is correct. All others have tried. Your answers are also correct. But he gave me the exact correct answer. So if an electron withdrawing group is attached to the ring, the incoming electrophile will go to meta position. If an electron donating group is present on the ring, then your electrophile will go to ortho position and para position. Okay, please don't forget. Please don't forget. You will get questions from these concepts. So don't forget these concepts. Okay. So this is all about the chemical reactions of carboxylic acids. So there were there were 4 categories. In the first category, I have discussed 3 reactions. In the second category, 4 reactions. In the third category, we have discussed about 3 reactions. In the fourth category, we had studied 2 reactions. Okay. So there are 11 reactions. 11 or how much? 4, 5, 6, 7. Yeah, 12. There are totally 12 chemical reactions which you have to study for carboxylic acids. All the 12 reactions are very, very important. Clear? I hope all the reactions that I have discussed is clear to all of you. Any doubt? Any doubt for anyone? You guys have any doubt? Shall we go for the uses? Okay, clear. Thank you, students. Now the very last topic of this lesson is uses of carboxylic acid. Going ahead with the uses. The first compound that I'm going to take is methanoic acid. So what is the formula for methanoic acid? HCOOH. One carbon containing acid is called as methanoic acid. So it is used in rubber industry. It is used in rubber industry, leather industry, for electroplating purpose, okay, for coating a metal with a solution. So electroplating purpose, and in dyeing industry and in textile industry. Okay, so methanoic acid is used in most of the industrial areas. Okay, then the next compound is ethanoic acid. What is the formula for ethanoic acid? CH3COOH. Two carbon containing acid. The very main important use is solvent. It is acting as a solvent for many compounds. Then it is used in vinegar. Okay. It is used in vinegar. Acetic acid is ethanoic acid, right? It is used in vinegar. Then if you go for the salt of carboxylic acid, sodium benzoate is a salt. The formula is C6H5COO. H means it is benzoic acid. If I put CO minus Na plus, it is sodium benzoate. It is a salt of benzoic acid. So it is used as a food preservative. Okay. And higher fatty acids, more number of carbon containing acids are used for the manufacture of soaps, detergents. Manufacture of soaps and detergents. And finally, the esters of benzoic acid. The esters means, benzoic acid means it is C6H5COOH. If I replace the hydrogen by some other alkyl group, for example, if I take CH3, this is the ester of benzoic acid. RCOOR dash. RCOOR dash. So the esters of benzoic acids are used in perfume industry. The esters are the compounds which have mainly the good smell. Okay, the good smelling compounds are called as esters. So that's why it is used in the perfumery industry. All right, so these are the uses of carboxylic acids. Let me summarize the reactions. So the very important reactions are esterification, reduction, soda lime, Holmes electrolysis, and HVZ reaction. So out of 12 reactions, these 5 are the very important reactions that you have to keep in mind. Okay, students. So with this, the lesson is getting over. And in the next class, I will try to go for the next chapter. All right. Do you have any doubts from this lesson? Everything clear? So start revising. Start learning the concepts we have discussed. Start solving the questions. So we can meet up with the next new lesson in the next class. Okay. So till then, take care for all of you. You can take care. Answer the questions. Answer the